This is SpaceTime, Series 22, Episode 10. Coming up on SpaceTime, new clues about the creation of the first supermassive black holes, a last-ditch effort to try and save the Opportunity Mars rover, and physicists looking for a successor to the world's largest atom smasher, the Large Hadron Collider. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests that the very early universe, and we're talking just after the Big Bang 13.82 billion years ago, may have seen conditions in which normal star formation was overtaken by the birth of monstrous supermassive black holes. The findings, reported in the journal Nature, also suggest that these gigantic black holes may be far more common across the universe than previously thought. Black holes are the most intense gravity wells in the universe. They're regions of infinite density in zero volume. Regions where the gravitational pull is so strong that nothing, not even light, can escape. Stars, planets, gas clouds and other matter attracted to the black hole by its intense gravity start swirling around the black hole in an accretion disk, like water draining out of a sink. Material in the accretion disk is crushed, stretched and ripped apart at the subatomic level, in the process releasing vast amounts of energy, before passing a point of no return called the event horizon and falling forever into the black hole's singularity. Some of the superheated matter in the accretion disk is deflected along powerful magnetic field lines, away from the event horizon, out towards the black hole's spin axis, where it's accelerated to relativistic speeds, forming intense jets called quasars, which are the brightest known objects in the universe, shining out like beacons, visible in the night sky more than 13 billion light-years away. Small stellar mass black holes are formed by the death of some of the most massive stars in the universe in powerful explosions called supernovae. Supermassive black holes, which are millions to billions of times larger, are found at the centers of most, if not all, galaxies. However, we don't know how these monster black holes are formed. Now, new supercomputer simulations suggest that when galaxies assemble extremely rapidly and sometimes very violently, instead of forming stars, the process can lead to the formation of extremely massive black holes. In these rare galaxies, normal star formation is disrupted and black hole formation takes over. If true, it means massive black holes form in dense starless regions that are growing rapidly, turning upside down the long-accepted belief that massive black hole formation was limited to regions bombarded by powerful radiation from nearby galaxies. The key criteria to determining where massive black holes form during the universe's infancy relates to the rapid growth of pregalactic gas clouds that are the forerunners of all present-day galaxies. One of the study's authors, Associate Professor John Wise from Georgia Tech, says that what this means is that most supermassive black holes have a common origin, forming in this newly discovered scenario. Dark matter collapses into halos that are the gravitational glue for all galaxies, and early rapid growth of these halos prevented the formation of stars that would have competed with black holes for gaseous matter flowing into this area. Wise says the simulations have uncovered a totally new mechanism that sparks the formation of massive black holes, in particular dark matter halos. Instead of just considering radiation, astronomers need to look at how quickly the halos grow, how the dark matter is distributed, and how gravity affects that. Forming a massive black hole requires being in a rare region with an intense convergence of matter. When the research team first discovered these black hole formation sites in their simulations, they were stumped. The previously accepted paradigm was that massive black holes could only form when exposed to high levels of nearby radiation, making it impossible for matter to form new stars. However, as the authors delved deeper, they saw that these sites were undergoing a period of extremely rapid growth. The violent and turbulent nature of the rapid assembly, the brutal crashing together of the galaxy's foundations during galaxy birth, all worked to prevent normal star formation from occurring, and instead led to the perfect conditions needed for the creation of a supermassive black hole. Earlier theories relied on intense ultraviolet radiation from nearby galaxies to inhibit the formation of new stars in the black hole forming halo. And while ultraviolet radiation is still a factor, the new computer simulations show it's not the dominant factor. The new computer models were based on the Renaissance Simulation Suite, a 70-terabyte dataset created between 2011 and 2014 to help scientists understand how the universe evolved during its early years. To learn more about specific regions where massive black holes were likely to develop, the researchers examined the simulation data, finding 10 specific dark matter halos that should have formed stars given their masses, but only contained a dense gas cloud. They then re-simulated 2 of these halos, each about 2,400 light-years across, at much higher resolution in order to understand the details of what's happening in them some 270 million years after the Big Bang. Wise says it was in these overly dense regions of the universe that black holes suddenly began forming. The dark matter creates most of the gravity, and then the gas falls into that gravitational potential, where it can either form stars or a massive black hole. The simulations allowed the authors to zoom in and observe the very earliest stages of the gravitational assembly of this pristine gas, composed mostly of hydrogen and helium in cold dark matter, leading to the formation of the first stars and galaxies. In fact, the resolution of the simulation was so good, it allowed the scientists to see turbulence and the inflow of gas and clumps of matter forming as the black hole precursors began to condense and spin. And their growth rate was dramatic. Astronomers observed supermassive black holes that had grown to around 1 billion solar masses in just 800 million years, a process requiring an intense convergence of mass in that region. Another discovery was that these types of halos, though still quite rare, may still be more common than previously thought, enough to produce most of the supermassive black holes in the universe today. The authors are now hoping to expand their computer simulations in order to see how these monstrous black holes will evolve into the future. Only time will tell. I'm Stuart Gary. This is SpaceTime. NASA is sending new sets of commands to try and force its Mars Opportunity rover to respond. The 6-wheel golf cart-sized rover went silent on June the 10th as a global dust storm enveloped the red planet for months on end, blocking out the sunlight needed to charge Opportunity's batteries. OPI, as it's affectionately called by its mission managers, has remained silent ever since, despite the dust storm having long cleared away. Opportunity most likely experienced a low power fault, a mission clock fault, and an up-lost timer fault, all traced back to the loss of power and the draining of the batteries. Mission managers expected the rover to return to full operational status once its batteries were recharged by the solar panels. But the rover's been silent ever since, ignoring more than 600 calls from Earth. Mission managers think the most likely reason is that dust from the storm has covered the solar panels, preventing them from receiving sunlight and charging the batteries. Normally, strong Martian winds, which usually begin to blow around November, would have blown away that dust. But still, there's been no contact. NASA's even tried sweep and beep commands designed to nudge the rover to send a response once the rover's powered up again, even if its internal mission clocks failed because of the storm. But still, OPI has not phoned home. Engineers with NASA's Deep Space Communications Network have now devised a new set of more powerful commands, which they hope will force Opportunity to make contact with Earth. The new commands are designed to deal with the possibility that Opportunity's 2 X-band radios have both failed for some reason. Though that's unlikely, mission managers are running out of options, so they're trying pretty well anything. The new commands will hopefully force Opportunity to both respond and change communication systems. However, there are now reports of fresh dust storm activity about 200 kilometres west of Opportunity's current location. And while that's primarily tracking south, it's nevertheless large enough to be expected to increase the tau, that is the opacity, at Opportunity's location over the next few days. This last-ditch effort to bring the little rover back to life comes just a day after NASA celebrated the 15th anniversary of Opportunity's landing on Mars. The spacecraft touched down on the Meridiani Planum near the Martian equator on January the 24th, 2004, for what should have been a 90-day mission. Opportunity had been launched from the Cape Canaveral Air Force Station in Florida 3 weeks after its twin rover Spirit on July the 7th, 2003. Spirit had touched down 3 weeks before Opportunity on the other side of the planet in Gusev Crater. Spirit continued operating for 2,269 days until finally getting bogged in a sand dune with its solar panels pointing away from the sun. It sent its final message back to Earth on the 22nd of March 2010, more than 6 years after landing. Of course, OPI continued operating much longer, covering well over 5,300 days on the Martian surface, examining rocks and minerals, and travelling more than 45 kilometres to its current location in Perseverance Valley, a gully leading off the rim of Endeavour Crater. You're listening to Space Time. I'm Stuart Gary. CERN, the European Organisation for Nuclear Research, has unveiled plans for a successor to its Large Hadron Collider, the world's most powerful particle accelerator. The proposed new atom smasher would be some 4 times larger and 6 times more powerful than the current Large Hadron Collider, and cost between $10 and $22 billion to construct. The Future Circular Colliders collaboration team says the new facility would take particle physics far beyond the horizon of the current Large Hadron Collider, in the process significantly expanding science's knowledge of matter in the universe. The ultimate goal is to build a 100-kilometre superconducting proton accelerator ring with an energy of 100 tera-electron volts and beyond, meaning an order of magnitude more powerful than the Large Hadron Collider. The new facility would provide electron-positron, proton-proton, and ion-ion collisions at unprecedented energies and intensities, offering the possibility of electron-proton and electron-ion collisions as well. The discovery of the Higgs boson, the Large Hadron Collider in 2012, opened a new path of research. That's because the Higgs could be a door to new fundamental physics. The Higgs is an elementary particle acting through a Higgs field to give all the other particles their mass. That's why some members of the press have called it the God particle. The new facility would move scientists to the next step in understanding the Higgs properties, and it would help scientists understand how the Higgs interacts with other Higgs particles. The different options being explored by the Future Circular Colliders collaboration team will offer unique opportunities to study the nature of the Higgs. The new particle accelerator could also explore the role of electroweak symmetry breaking in the history of the universe. That's when the electromagnetic and the weak nuclear forces split apart. It would allow scientists to access unprecedented energy scales, looking for new massive particles. It would collide heavy ions, sustaining a rich heavy ion physics program to study the state of matter in the early universe. And it would start to tackle new physics beyond the standard model. Things like dark matter and dark energy, and the asymmetry of matter over antimatter, none of which can be explained by the standard model of particle physics, which is the foundation stone of modern physics. Building such a massive particle accelerator will be done in various stages. Firstly, there'd be a high luminosity 90 to 365 giga-electron-volt electron-positron machine. Such a collider would be a very powerful Higgs factory, making it possible to detect new rare processes and measure the known particles with precisions never achieved before. These more precise measurements would in turn allow far greater sensitivity to possible tiny deviations from the standard model's expectations, which could be a sign of new physics beyond the standard model. The cost of the initial large circular electron-positron collider would be somewhere around €9 billion. That includes €5 billion for the civil engineering work needed for a 100-kilometre long tunnel. But such a collider could serve the worldwide physics community for up to 20 years. The new physics program could start by 2040 at the end of the high luminosity Large Hadron Collider. The cost estimate for a superconducting proton machine which would use the same tunnel would be around €15 billion, and that machine could start operations by the late 2050s. The Large Hadron Collider is a 27-kilometre long ring buried 100 metres beneath the Franco-Swiss border near Geneva. Part of a large complex of particle accelerators, synchrotrons and other high-energy laboratories, the Large Hadron Collider includes 4 massive detectors, ALICE, ATLAS, CMS and the L8CB, each located in a massive underground cavern. Packets of protons and other subatomic particles are accelerated to within 99.999% the speed of light in opposite directions in 2 particle beamlines around the ring, guided by cryogenically cooled superconducting magnets. The beamlines can intersect at any of the 4 detectors, colliding the particle packets at 13 tera-electron volts, and creating the sorts of conditions, pressures and temperatures that occurred just after the Big Bang 13.82 billion years ago. I'm Stuart Gary. You're listening to Space Time. Japan has launched a satellite designed to deploy an artificial meteor shower over Hiroshima. The Japan Aerospace Exploration Agency's Epsilon 4 rocket blasted off from the Uchinori Space Center south of Tokyo, carrying 7 miniature satellite payloads into a 514-kilometer high orbit. While 6 of the satellites will undertake various scientific experiments, the 7th carries 400 tiny balls designed to burn brightly once released and rain down back through the atmosphere. The Tokyo-based startup company behind the so-called Shooting Stars on Demand service says the spacecraft's programmed to deploy up to 20 of these tiny chemical balls at a time, designed to glow brightly for several seconds before completely burning up. The flight was the 4th mission for the Epsilon solid-fueled rocket and the first to carry multiple payloads. China has carried out its 2nd launch for 2019, carrying 4 new satellites into orbit. The solid-fueled Long March 11 launch vehicle blasted off from the Zhuquan Satellite Launch Center, carrying the Jialin-1 Spectrum 01 and 02 hyperspectral imaging satellites. These will join a growing constellation of miniature Earth observation satellites developed by Beijing using multispectral and infrared imaging systems. Also aboard the flight were the Lingqiu-1A verification satellite, which will test communications between orbiting satellites, and the Zhaozhang 103 satellite, which will test radio communications and remote sensing technology. The launch was the 299th mission for the Long March series rocket. And time now to take a brief look at some of the other stories making news in science this week with a science report. Greenland is melting faster than scientists had previously thought, and will likely lead to faster sea level rise thanks to the continued accelerating warming of the Earth's atmosphere. Scientists concerned about sea level rise have long focused on Greenland's southeast and northwestern regions, where massive glaciers stream iceberg-sized chunks into the Atlantic Ocean. Those chunks float away, eventually melting. But a new study, reported in the Proceedings of the National Academy of Sciences, has found that the largest sustained ice loss from 2003 to 2013 came from Greenland's southwest region, which is mostly devoid of large glaciers. Whatever this was, it couldn't be explained by glaciers because there aren't many there, so it had to be the surface mass. The ice on the ground was melting inland from the coastline. That melting, which is largely caused by global warming, means that in the southwestern part of Greenland, growing rivers of water streaming into the ocean during summer, and this is likely to be a major contributor to sea level rise. A new study claims regular use of anti-inflammatory drugs such as aspirin or ibuprofen could help patients with head and neck cancers. Scientists found that regular use of these drugs lowered the levels of inflammatory molecules found in patients with head and neck cancers, helping to improve survival and recovery. You can read more about the findings in the Journal of Experimental Medicine. A new study throws into question the notion that today's crocodiles, alligators and caiman have a simple evolutionary past. Previous research has pointed to crocodiles, caiman and alligators starting with land-based ancestors some 200 million years ago and then gradually moving to fresh water to become the semi-aquatic ambush predators they are today. But a new analysis, published in the journal Scientific Reports, offers a different story, claiming that modern crocodiles, caiman and alligators came from a variety of surroundings beginning in the early Jurassic, and various species occupied a host of different ecosystems over time, including land, estuarine, freshwater and marine. Transitions between land, freshwater and sea were more frequent than thought, and the transitions themselves were not always from land to freshwater or from freshwater to marine. Scientists pieced together crocodile, caiman and alligator ancestry by analysing a large family tree showing the evolution history of living and extinct crocodiles, caiman and alligators. A new study has found that postmenopausal women who regularly eat fried food have an increased risk of heart-related death and death from any cause. The findings, reported in the British Medical Journal, are based on questionnaires assessing the diets of 106,966 women aged between 50 and 79. Researchers found that foods such as fried chicken or fried fish or shellfish were associated with a higher risk of heart-related death, especially among women aged 50 to 65 years. Fried chicken was the deadliest fast food. Eating it every day increased the risk of death by 13% and the risk of heart-related death by 12%. Up to a third of North American adults eat fast food every day. Previous studies had already suggested that a greater intake of fried foods was associated with a higher risk of type 2 diabetes and heart disease. Anti-vaxxers are being blamed for a 30% jump in measles cases. The huge increase in measles has been seen in both Europe and the United States. However, the trend has not been repeated in Australia, where government programs designed to encourage immunisation have paid off, with immunisation coverage rates in children hitting record highs. Tim Mendham from Australian Skeptics says the figures from America and Europe shows how dangerous the anti-vaxxers can be.
This is really scary stuff. I mean, it's a major increase in measles cases around the world. So there seems to be a real boom in the anti-vaccination, the impact of the anti-vaccination. Way back when Andrew Wakefield did his report on supposedly autism linked to the MMR vaccine, and people got very worried in the UK, measles vaccination dropped and cases of measles soared. And then that seemed to die out a bit when there was proof that Andrew Wakefield was shonky. But since then, the measles has come back. The danger is that people do not see measles anymore. When I was a kid, a lot of people had measles. A lot of people got seriously damaged by measles. A lot of people used to die of measles because through vaccination it died out, and suddenly people have become complacent, and it's come back again. And it's come back with a vengeance. In Europe especially, but in the US and increasingly in Australia, the numbers of cases of measles has increased. Measles at its height was killing about 2.5 million people a year, a lot of it in third world countries. That dropped in about 2016, I think it was, to about 80,000 a year dying. We're talking about not people who were medically damaged by it, they used to have encephalitis, all sorts of things, but killed by measles was dropped to 90. It's now back up to about 120,000 a year. People dying of this disease that we almost had wiped out, except the anti-vaccination movement kept making comments that, measles never killed anybody. You can have measles parties where you can bring your kids along and they can all catch measles and it'll all be great for them. Total stupidity, total irresponsibility. People are paying with their lives, and it's little kids, by and large, who are paying this price because their parents are not doing the right thing.
That's Tim Mendham from Australian Skeptics. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.